Inferring characteristics of an element with some practice questions. Let's start with this question up here. Number 17. Identify the following elements. We have to find out the elements of each single one for A and B and write the condensed electron configuration for the atoms of each element. Well, let's first look at the D block element. So the D block starts in the fourth period, right over there. So started in red. So right over here in that fourth period, you can see that the D block starts right over here with the transition metals. All right, with 10 valence electrons. So what we can do is just literally count from the D block right over here and just count 10 electrons. So all we really need to do is go from here and count 10. Why am I doing this? Well, look, we have 1, 2. So that fills up our 4 number because that is our highest principal quantum number. 4s needs to be filled up first before we start getting into the 3Ds. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is our number? I'm sorry, what is our element? Our element turns out to be Ni, which is nickel. So nickel here is our answer. So again, how do I know that this needs to be filled up before this? Let me show you our 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7p. So you can always just follow this off-bar principle method, and it should be quite crystal clear as we increase the energy levels. So where is our 4? Where do we first see 4? It's first popping up here, right? Our 4s. After 4s, as we increase, then we get to our 3d. So it is more energy intensive here with 3d. So we start with 4s, then we go to the 3d, then we eventually go to the 4p, okay? However, we don't really care about this 4p. We only care about the 3d because that's pretty much what the question is asking. Fourth period, so we got to start with our 4, and it also asks us in the D block, okay? So this here is our D block, okay? Again, it's going to involve the D block. Is it going to fill up complete D block? Nope. Just I mean yes, it says 10 valence electrons, okay? Does that mean these 10 electrons fill up this 3D? No. It could, but not particular with this number, because valence electrons always starts at the period number or the highest principal quantum number. 10 valence electrons doesn't mean that the 10 here fills up this D block. It might not necessarily do so. You have to fill up the 10 valence electrons and hit this number of 10 once you establish where the starting point is, and the starting point is going to be the highest principal quantum number. As soon as it says period 4, you know that's the highest principal quantum number. That's the n is equal to 4. You must start here, and then from there you can start adding 10 valence electrons from that point. So if I were to kind of draw this out, so let's say we have, our stuff from here. I got my 1s, we got our 2s, we got our 2p's, then our 3s, then our 3p's, then our 4s, and then our 3d's. Okay? If I were to fill this all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I got to go here first based on this rule. It's 18, 19, 20. Okay, so right now we have about 20 electrons. But where is our valence electrons? This is not our valence electrons, the one that we haven't filled up yet. This is not. Our valence electrons start from the highest principal quantum number, which is 4s. So we started here at 2. Okay, so we started here at 2. We got to add 8 more then. So we got 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we got to count it all up. All right, so we got to here. Okay, that gave us 20 electrons. So 22, 24, 26, 27, 28. 28 electrons. Where is that on the periodic table? This is obviously going to be nickel. Oops, let me do it in red here. This is going to be obviously nickel. Okay, this has 28 electrons. So our answer is obviously going to be nickel. Hopefully that makes sense. All right, let's give that a try, our period 6. So again, we don't need to be going through this method, okay, rigorously with this, but if it helps you understand, I'm going to do it for you, okay? So let's keep trying. And let's start, again, from where we are right now, and let's just keep adding upwards. All right, so we got to the 3Ds, okay? Eventually, we need to get to our period 6, okay? So let's get to period 6 right away. So again, we're at 3D right now, so we're here. We eventually need to go to the 4P. So let's start drawing our 4Ps. Okay, and after the 4P, we're going to our 5Ss. After the 5Ss, where are we going? We're going all the way up to the 4Ds. Okay, so we're going to go to our 4D here. All right, after the 4Ds, we're going up to a 5P. So let's go to our 5P. And then after the 5P, we're going to the 6Ss. And then after the 6Ss, we're going into the 4Fs. There we go. All right. So as we continue to fill this up, again, just fill them up all the way until the period 6. Okay, we don't necessarily need to count them right now. So again, after the 4S's, we got to get to our 3Ds. We did that. After the 3Ds, we're at our 4Ps. So add them accordingly. And then our 5S's. After the 5S's, we'll go to the 4Ds. After the 4Ds, go to the 5Ps. After the 5Ps, you go to our 4Fs. Sorry. After the 5Ps, we go to our 6S's. All right, so here's our 6S. So all we need to do is count from our 6S. All right, so we've added 2 valence electrons. Remember, the valence electrons get added with the highest principal quantum number. So that's obviously 6 because n is equal to 6. So we got 2 over here. We need 1 more to fill up 3 valence electrons. So it's going to be over here. All right, so if I were to figure out what did we do, well, we need to figure out from here 6. We're at 1, 2, 3, 4, 5, 6. So this here is 6. All right, if this is where the 6 is, we need to figure out after that where we added our 2 electrons here. So 1 electron was here, 1 electron is here. Where does this, so this is already finished, where does this go? This last electron. It goes into the next shell. So 1, 2, 3. So LA is our answer. So this is LA. All right, so the answer should be lanthanum. All right, so that would be our answer. All right, next question. Without a periodic table, so imagine we cannot see this periodic table here. And based on the condensed electron configuration, so just exit this out, we don't need this right now. And based on the condensed electron configuration given below, identify the group number, period number, and the orbital block. Hopefully you looked at the previous video where I showed you the formulas and the steps as to how we got those and how do you know which one to pick. If you haven't, please go back to that video and watch it. I'm going to write the formulas here anyway, but it's probably very beneficial that you do that first. All right, so we got the NS. And then we have our NS plus NP plus 10. And then we have the NS plus N minus 1 times D. All right, let's start looking at our Rn 7s1. Well, as we can see, 7 is the highest principal quantum number. So that means our period number is going to be 7. What else? What is the last letter of that shorthand configuration? It is S1. So S is going to be our block number. Sorry, block. All right. So that's the orbital block that's mentioned in the question. So we've done the period number, we've done the block, now we got to do the group number. All right, the group number is going to be calculated, but we have to figure out which formula to use. Again, in the video that I created before this for inferring characteristics of an element, the foundational knowledge part of that video, please watch it. The group number is going to be calculated using one of these formulas, and it's going to be decided based on the block. So if this here is our block of S, we're going to be using this one because this is going to be our S, this is going to be our P's, this one's going to be our D's. So number of electrons in the S, how many? There is 1. This has to be group 1. B, tungsten. We'll look at the period number. The highest principal quantum number is 6. So our n value is 6. So our period number will have to be 6. Next, we have to look at the very end. It is D. So our block is going to be D. Lastly, we need to look at the sum using the particular formula that is going to be that's going to give us the correct answer. So our sum needs to be in the D. So this here is going to be what we're going to be calculating. So NS, again, the number of electrons within that block. So in our S we have 2, so we've got to put 2. N, again, this N relates to the S. So again, we have that same 2. You minus 1, and then you multiply by the number of electrons in the D. So you have 4. So it becomes 4. So you just 4 times 1, 4 plus 2 gives you 6. Hence, it is 6. So your group number is going to be 6. Hopefully this is making sense to you. All right, so 6, 6, and then D. All right, let's do the last one. Let's do C. All right, antimony. We have to look at our highest principal quantum number. It is 5, so period number is going to be 5. And then after that, we got to look at our block. It's obviously going to be P. And then after that, we got to be doing our sum. Are we going to be using the formula for this, this, or this? It's obviously going to be this second one. So we have to use number of electrons in the S block. It's going to be 2. So we're going to put 2 here. All right. After that, we need to plus NP. Okay, so number of electrons. Okay, for P. So how many are in the P? There. Sorry, right over here. Yep. How many are there? There is 3. So we got to start adding 3. All right. After that, you just add it by 10. So you just give a sum of all of them up together. You end up getting 15. So the group number is going to be 15. That's it for that. I'm going to give you 3 more questions. I want you to give this a try on your own, and hopefully you'll be able to get them okay, and I'll show you the answers right after. All right, please try this question over here. Without a periodic table, based on the condensed electron configuration given below, identify the group number, the period number, and the orbital block. So, group number, period number, and the block. All right, so do this for B and C, and then hopefully you get it right. If you have any questions, please comment below, and then I'll be sure to reply as quickly as I can. All right, so again, please pause the video because I will be posting the answers immediately. These are the answers. Tell me how you did.